Hi, and thanks for joining me in this video about ground de-icing of aircraft. In this video, we'll start out talking about the regulations for ground de-icing. After that, the problems associated with ice on aircraft before they depart. We'll talk about how we can solve that problem, and then finally talk about freezing point depressants or FPDs. There are several regulations about ice adhering to aircraft before departure. They're in Part 91, 125, 121, and 135. And they all deal with the clean aircraft concept, which states takeoff may not be attempted until the pilot in command determines that all critical surfaces are free of ice, snow, and frost. The regulations are very clear that the pilot in command is ultimately responsible for ensuring that the aircraft is clean of any ice adhering to its structures. Also, the pilot in command may obtain verification from properly trained and qualified ground personnel who can verify that the aircraft is clean of ice. We will now discuss why ice adhering to an aircraft is a problem. At takeoff, aircraft wings are generating large amounts of lift with little margin for error in an effort to get airborne. Large aircraft are most vulnerable to ice adhering to the wings during takeoff. Here are a number of accidents over the years showing large aircraft that had crashed as a result of improper ground de-icing as a result of ice adhering to the wings. Ice adhering to critical surfaces on an aircraft will reduce lift up to 30%, increase drag up to 40%, reduce the controllability of the aircraft, it alters its flight characteristics, and finally, it increases its stall speed. Aircraft manufacturers have devised a solution for ice adhering to aircraft structures. The solution to this problem is one of two actions, either to de-ice the aircraft or anti-ice the aircraft. De-ice means to remove ice from the aircraft, whereas anti-ice means preventing ice from forming on the aircraft. The de-icing method depends upon the type of contaminant that is adhering to the airframe. If it is dry snow, then it can be just brushed off or blown off with compressed air or even a leaf blower. The ice is adhering to the airframe and the wings, then a freezing point depressant must be used. This method is called ground de-icing. There are several different types of freezing point depressants, or FPDs, and we'll talk about those now. Freezing point depressants are made of primarily ethylene glycol or propylene glycol. There are different types of additives that will change the viscosity of the fluid, and as a result, we have four different types of solution. Type 1, 2, 3, and 4, which may be applied to aircraft either heated or unheated. Type 1 solution is colored orange. It is of low viscosity, which means that it is not very thick. It flows very easily. It's recommended for de-icing and may be pre-mixed. You might be able to get it from a manufacturer already mixed in a 50% solution, 50% water mixture. And it should not be used neat. Neat meaning at full strength or 100% solution. The reason is because you'll have a higher freezing point. In other words, ice will form at a warmer temperature. And also you may have a lift reduction at temperatures colder than -10 degrees Celsius. Type 2 solutions are clear. They are of higher viscosity, which means that they are thicker and adhere to the wings for a longer period of time. So that's why the manufacturers recommend that this be used on aircraft that have rotation speeds greater than 85 knots so that the stronger wind will shear off the solution from the wings and allow the aircraft to climb without any degradation in lift. It's recommended for anti-ice because it sticks on the wings longer and it protects the wings. However, as it shears off the wings and falls onto the runway, it makes the runway slick, so there are some concerns over runway friction. Type 3 solution is a compromise between type 1 and type 2. It's not as thick as type 2, but it's a little bit thicker than type 1, typically used for aircraft with lower rotation speeds, less than 100 knots. As I mentioned, it's not as viscous. It's recommended for anti-ice, but you really don't see it used very often at airports. Type 4 solution is green. It has the same viscosity as type 2, so it's pretty thick. And also it has holdover times that are longer than type 2. And as a result of this high viscosity, it sticks on the airframe longer, so aircraft with rotation speeds greater than 85 knots typically use this. And this is the most common type of anti-ice solution that you'll find used at airports across the United States. When flight or ground crews determine that de-icing or anti-icing needs to be performed on an aircraft, they have to calculate the protection level. The protection level is the temperature to which the FPD or the freezing point depressant is effective. Water usually turns to ice at 0 degrees Celsius. If you have a solution that is applied to an airplane that is a mixture of water and also freezing point depressant, then the temperature at which ice forms is much lower. It may be -10, -20, or colder. The temperature at which ice will form depends upon the solution strength. This figure, taken from Advisory Circular 120-58, shows the protection level for various types of solutions. The horizontal axis is the FPD strength, in other words, the percentage of fluid to water, and the vertical axis is temperature on the left side in degrees Fahrenheit, on the right side in degrees Celsius. The curves show different types of solution. Notice that as the solution strength increases, as it goes from 0 to 20 to 40 to 60% solution strength, in other words, as the solution gets stronger, the mix, notice that the curves go down, meaning that the protection level increases, or the temperature at which ice forms decreases. One anomaly to this is ethylene glycol and diethylene glycol, the blue and black lines. Above 70% as the solution strength gets stronger, all the way up to 100%, notice that the protection level increases. It goes from a temperature of -50 degrees Fahrenheit up to 10 degrees Fahrenheit. These solutions are all type 1 solutions. However, there is one red line that indicates type 2 solution. De-ice and anti-icing operations are very time-consuming and also costly. So here are the guidelines for FPD use. Above all else, safety is the most important factor. Aircraft that are departing and taking off need to be clean of ice. Therefore, enough solution should be used to remove the ice and prevent ice from forming on the aircraft before it departs. Number 2 is the environmental impact. Solution that is applied to an aircraft eventually ends up on the ramp. That solution may end up in the groundwater or the surrounding reservoirs. As a result, the FPD use must be minimized to make sure that there are no environmental hazards. That provides a quick overview of ground de-icing and anti-icing operations. Watch my other videos for more information on ground de-icing and anti-icing.